Hello students, today we are going to start a new chapter, that is moment of inertia. What is moment of inertia? Let us begin with the definition, but before that, remember that it is the second part of center of gravity itself. So to understand this chapter very well, you just have to refer the center of gravity first. You must remember all the formulas of center of gravity of rectangle, triangle, circle, semicircle, quarter circle, all the areas. Okay, only areas are required, no one dimensional elements are required. Okay, now what is moment of inertia? It is actually the second moment of area. You must understand mass moment of inertia. Perhaps in the physics you have studied about the mass moment of inertia. I equal to mk square, where m is equal to mass and k equal to radius of gyration. What is inertia? Actually, it is the opposite force. Inertia force is the opposite force of accelerating force. Maybe you have studied in the example that when you are traveling on the vehicle and suddenly the vehicle stops, then you are going ahead, or when the vehicle starts again suddenly, then you are going just back like this. So that is the effect of inertia. But in this case, it is not like that. We have discussed that is mass moment of inertia. But here it is area moment of inertia. Area moment of inertia means we have to take some product of area with respect to distance. Let us see how. See, this is basically not the thing which is visible. Means you cannot say like that, here it is moment of inertia, that is moment of inertia. You cannot say like that. Okay, so moment of inertia is not visible. Actually, it is the invisible quantity. It is a matter of calculation only. So moment of inertia is denoted by capital I, but it is important for the design purpose only. Okay, it cannot be visible, it cannot be so easily identifiable, but it is only used in the calculation. Now how it is useful in the calculation? What is importance of it in the calculation? Let us see how. See, this is the definition of moment of inertia on your screen, its importance and its unit. Here you can see there is an area of unusual shape like this. It is called as lamina of area A. From there, just consider a small area dA like this, small area dA. Now, this distance from y-axis is denoted by x. Suppose horizontal distance, so it is x, and this is the distance of the small area from x-axis. It is the vertical distance, so it is denoted by y. Now, let us consider a lamina of area A shown in figure. Let this lamina is split up into infinite number of small elements of each area dA. So I have considered one area dA. You just consider lots of areas like this. Let x1, x2, x3 are the distances of small elements of from y-axis. Means from y-axis this distance is suppose x1. If here it is suppose part 2, then the distance will be x2. If here it is suppose part 3, then distance will be x3. Similarly, vertical distances are y1, y2 and y3. So these are the vertical distances from x-axis. Now, taking second moment of all the small elements about y-axis. Now, what is second moment? What is actually moment in the case of beams? Moment is equal to force into perpendicular distance. While in this case, moment is equal to area into distance square. So that's why it is known as second moment of area. Remember this. That's why this is known as second moment of area. Now it is denoted by Ixx, where what is I? Capital I is denoting moment of inertia. Now, while we are taking moment of inertia, it is important that about what axis we are taking moment of inertia. About x-axis, about y-axis, about any other axis, about centroidal axis. Now, these are the various names. What is the x-axis? You already know. What is y-axis? You already know. Now, what is centroidal axis? There are two types of centroidal axis, vertical centroidal axis and horizontal centroidal axis also. What is centroidal axis? The axis which is passing from the centroid of the area. The area may be rectangle, triangle, or combination of the rectangle, triangle, or circle. Anything. So, when the axis is passing from the centroid or combined centroid of the total lamina, then if that axis is horizontal, then it is known as horizontal centroidal axis, and if it is vertical, then the axis is known as vertical centroidal axis. So, here you can see the moment of inertia is denoted by Ixx. So, what is Ixx? I means moment of inertia, as I said. And what is Xx? Xx means the moment of inertia is running about this XX axis. So all the areas multiplied by square of the distances with respect to this x-axis. You can see for the first part dA into y1 square. What is dA? This is small area dA. And what is y1? This vertical distance is y1 from the x-axis. You have to take square of this because it is known as second moment of area. So this is basically the formula. You have to remember this formula approximately. So dA into y1 square. So you just remember that you have to mug up this formula, area into distance square, area into distance square, area into distance square. So that is known as moment of inertia. If you are taking second part, then this element having area dA, vertical distance is y2. So it is dA into y2 square. Similarly, dA into y3 square and so on. Okay, so these are the various small elements dA and distances are y1, y2, y3. So basic definition of the moment of inertia is area into square of the distance about particular axis. So by taking the algebraic sum, sigma dA will denote capital A means area of lamina. So dA is common out and it is known as sigma dA for the algebraic sum into y square denotes vertical distance from the x-axis. So moment of inertia about x-axis will ultimately area into y square. Now what is the unit? You can check the unit from this formula itself. What is the unit of area? The unit of area is meter square or mm square or centimeter square, like that. And what is y? Y is the distance in mm, meter or centimeter, but here it is square. So meter square of area and meter square for this y square. Okay, so total unit will be meter raised to 4. We are using smaller units like centimeter raised to 4 and mm raised to 4. So these are basically the units of moment of inertia. So we have discussed about moment of inertia up to x-axis only right now. It is possible that moment of inertia can be found out with respect to y-axis, with respect to centroidal axis, with respect to any other axis. Then accordingly the name changes. Here it is Ixx right now, but it may be Iyy, it may be Izz, it may be Iab, it may be Ig. Okay, G means centroid. So it can vary with respect to axis. Let us see the same moment of inertia about y-axis. Then what happens? Here you can see, consider the same figure and find Iyy. Then all the distances of the small elemental areas are taken from y-axis. So dA is the first area and horizontal distance will be x1. From y-axis it is x1. If here it is second area, then from y-axis it is x2. So dA into x2 square. For the third area, dA into x3 square. If you are taking the algebraic sum, then Iyy will be sigma dA into x square. Okay, sigma dA means summation of all elemental areas. X means distance from y-axis. Now what is Iyy? Finally, area into x square. So if it is Ixx, then it is answering ay square. But here it is Iyy, So it is answering ax square. Ultimately, the unit will be same. Unit of area will be meter square, and unit of distance is also meter and the square as it is. So final unit of moment of inertia is meter raised to 4, mm raised to 4 or centimeter raised to 4. Second moment of area is called moment of inertia. Here it is the very simple definition. If it is asked in the exam, then you can write down like this very simple definition. Second moment of area is called moment of inertia. Unit of mi is mm raised to 4 or centimeter raised to 4. You can write also meter raised to 4. Now what is short form? Here it is, you can see mi. So now onwards we are calling it mi, means moment of inertia. Okay. Now you are wondering just that what is actually the importance of this topic? What is the moment of inertia? How it can affect the civil engineering? Okay. So as I said, moment of inertia is the thing which cannot be visible actually. Okay, it is just a matter of calculation. It is denoted by M. Now, how it is a matter of calculation in the design of structures? Okay, so let us see one example. Actually, this design will be coming in next chapters, upcoming chapters, while we are going to study strength of materials, while you are going to study structure analysis 1 in the 4th semester. Okay, so for example, as of now, just concentrate on this formula. Suppose sigma upon I is equal to M upon Y. This is the bending equation actually. What is bending equation? Which gives the calculation of bending stress for the beam, for the columns, etc. Suppose you are designing a beam in your home, or you are designing the beam in the commercial complex. Then what happens? Then here it is, first quantity sigma. Sigma means the stress the beam can carry. M means bending moment. Bending moment, you are already studied about this. Bending moment is equal to force into perpendicular distance. Y means certain distance from the axis. As you can see in this theory, suppose the area is dA of the beam or any cross section of the beam, then up to certain axis its distance is Y, about which you are taking moment of inertia, that is I. Now you can see what is our target. Our target is to reduce the stress on the beam. Okay, so that the beam's life can be extended. Okay, beam can everlasting. So what you can imagine from this formula? From this formula you can see if the value of I is increasing, okay, value of I is increasing, then if I is going into this M, cross multiplication into M, then sigma will be rising. Okay, sigma will be rising. So it is just the mathematical expression. If sigma is rising, then it is very dangerous for the beam. Okay. Actually, I have made some mistake. This formula can be rearranged, or this formula is mistaken by me. It is like this: sigma by I is equal to, sorry, if you are doing cross multiplication, then what happens? Sigma is equal to mi by y. So you have to reduce actually moment of inertia. Okay, if you will reduce this portion, this I, value of moment of inertia can be reduced, then the stress of the beam will also reduce, as they are directly proportional. So our target is to reduce, to minimize the moment of inertia, to save the beam, to make the beam very safe. As the stress reducing, the beam will become safe. So it is just a one example. So moment of inertia is used in this type of calculations only. So it is not the thing which can be visible. Okay, you cannot see like this. This is moment of inertia, this is moment of inertia, that is moment of inertia. It is not like that. It is just find out with the help of calculator in your Calci. You can find out the moment of inertia for rectangle, triangle, circle, semicircle, etc. shapes, also for the combination of the shapes, and you just replace the value of this moment of inertia into the equations, into various equations to design the structures and to check the safety of the structures. So I is a very small component which can be used in the design purpose only. So in the next lecture we will discuss some basic formula for moment of inertia of rectangle and triangle. Actually we will derive the equation for the moment of inertia of rectangle and triangle with the help of first principle. So till then, just revise this theory at your own. If you revise this theory, it is just for the theoretical concept of point. It can be asked for 1 or 2 marks in your GTO exam. From the next lecture, very important derivations will be starting. So please concentrate in the next lecture. Till then, thank you. Goodbye, students.